Okay, so my name is Björn Witha from ForWind, University of Oldenburg in Germany, and I'm presenting you the Ferry LIDAR experiment we carried out in the NEWA project. The experiment was mainly done by my colleagues from Fraunhofer IWES, and I will be managing the corresponding benchmark for this experiment. And of course, this is what I'm going to introduce as well now. So the Ferry LIDAR experiment is a very unique kind of experiment. So something very different from the usual tall mast experiments you have. Actually, what we did is we put, or the Fraunhofer colleagues put a ship LIDAR system, a simple LIDAR system on a ferry boat, which is traveling through the southern Baltic Sea on a daily route. So it takes 2 days for a return trip. And the ferry route was from Kiel in Germany to Lithuania. So it crosses the complete southern Baltic Sea. And we put that LiDAR there on the boat for a period of 4 months and collected wind profile measurements continuously along the ship track for these 4 months. And it's really a unique data set, and to our knowledge, it's the first data set of such wind profile measurements along such a long ship track. And we recently published the experiment in remote sensing. You see the information here. So a few words about the ship LiDAR. It's basically very simple. It's just a standard LiDAR put on a ship deck, and of course the data needs to be corrected for the motion of the ship. So we have a reference attitude and heading reference sensor combined with the LiDAR and the satellite compass, and also weather station. So this is basically more or less the ship LiDAR system. This was developed by Fraunhofer IWES. You will find a link to a publication also at the end of this presentation. And this has been developed some years ago, and the accuracy of this system has already been proven in a dedicated verification campaign. Some results from the experiment. So how do the results look like? This is just an example period of 4 days measured. In this period of 4 days, the ship went twice from Germany to Lithuania and back. We can see here the wind speed and wind direction in different heights. We measured from the lowest level was, I think, 40 meters, and the highest level was about 300 meters. It's very interesting to see different periods of strong or weak wind shear and also strong and weak wind veer. We can quite easily identify the periods when the ship is in the harbor. Usually the wind speed is much lower, and you have a different kind of wind profile because there we have strong land effects. We are not offshore anymore. So these were some results from the experiments. What we did is we did an initial comparison with mesoscale model data. So this is also what the benchmark will be about. We did already such an initial comparison. We used the WRF model, and in an offshore optimized setup we had previous experience with. So I think the details are not so much important here. Let's have a look on the results. These are the model results compared with the observations. We took one height, 100 meter height above sea level. This example shows a period of 2 days in February 2017. And basically these comparisons look like what you would also expect if you would compare WRF with a single tall mast measurement. So we have a general very good matching of the data, of the simulated data with the observed data. You can actually see that the periods when the ship is in the harbor, that during these periods usually the results are not that good. So the model predicts usually higher wind speed. This is because when the ship is in the harbor, it's in a kind of a sheltered environment, which is not that much covered by the model. So, and sometimes, as we took the nearest grid point, sometimes the grid point is still offshore, while the ship actually is more or less onshore in the harbor. So, but this is how such comparisons look like, and this is what we also are intending to do in the benchmark. So this is just a sample of 2 days, but we did this for the whole period. This is another example of a storm situation where we had very high wind speeds, above 20 meters per second, and you can see also this situation was quite well covered by the model. Okay, now I'm going to introduce the Ferry LIDAR benchmark. It is a benchmark intended for mesoscale models. The motivation behind this benchmark, or you could also say the objectives of this benchmark, is we want to find out how well can mesoscale models reproduce offshore wind conditions. It's actually, we have to say, it's not really that much offshore. We are in the southern Baltic Sea. It's an enclosed sea, enclosed by land. So it's not really offshore like out on the ocean. So you still have land effects, and that is what makes this benchmark actually quite interesting. So it's not just a boring offshore situation, but you have land effects. And would be really nice to find out how, on the one hand, different models, and on the other hand, so different mesoscale models, and on the other hand, different model setups of the same model behave in such a condition. And of course, furthermore, this kind of data set is something new. It's not a typical data set you would use for verifying or validating your model. So it is also about to explore this kind of validation with moving profile measurements, and to see what are the strengths of these kind of validation, and of course there are also weaknesses, and it's just to explore this new kind of comparison. As I already said, it will be both a model intercomparison, so we hope to get not only WRF but also other mesoscale models as participants, but likely most of the participants will use WRF, and we will have a lot of different WRF setups, hopefully, and this is also one goal of the benchmark, to compare these setups. The first step, so this benchmark is mainly a blind test. You are just invited to use your best practice setup. So we do not specify anything else than the location and the time period. So just use what you think would fit best in such a location condition. But you're also, of course, free to run different setups, more than one setup. In a later stage, we might open a second benchmark later on, where we prescribe part of the setup and maybe focus only on WRF, but this will be later in a separate benchmark. In this first step benchmark, it's really complete open to the participants. So just use your best practice setup, and then it will be exciting to see what range the models will cover, how the spread between the models will be. So the only thing which is provided by us actually is the target domain, of course, the track of the ship, which has to be covered by the simulation. Of course, the model domain can be larger, it's up to you. And the time period to be simulated, it's just the duration of the experiment from 6 February to 8 June of 2017. As the data you will produce in the simulations is, of course, very large, and it will be difficult to submit the complete output fields, we will likely provide to you either the ship path, so that you can extract data from the closest grid points along the ship paths by yourself, or we might also provide some script which you could use for extraction of the data. we will finalize this in the next days. So it's not yet fixed. The output you have to deliver. We need, of course, the horizontal wind speed and the wind direction. And it would also be nice to have information about the temperature. So then we could draw some conclusions. We can relate the wind profiles to the stability then. And yeah, this should be along the ship path. As I already said, either you should extract by yourself the output along the ship path. We will provide the ship path, of course. And very important is that the data should be in NetCDF format, and that these NetCDF files should also include metadata as latitude, longitude, time, the timestamp. Mandatory is to submit the output in 100-meter height. So either you interpolate your model levels to exactly 100 meter, or you take the closest grid points if it's not too far away. If possible, we would also like to have further levels so that we can really check the wind profiles and compare the wind profiles. So further heights would be between 50 and 250 meters. Very important, as in each benchmark, is of course the setup information, which setup did you use in the model. So we will provide a template for a model evaluation questionnaire. And of course, you're free to give us as much information as possible about this. Of course, these results will be quite some amount of data, so we will probably provide a link to you where you can upload the data later on. So after the results have been submitted, we will run an algorithm to synchronize the model output with the measurements. It's quite tricky because, as you can imagine, the ship moves in time. So at each time step, we have to analyze a different location. That's something we will do. And of course, then compare with the time series of the ship LiDAR. So the first thing we compare will be the whole time series of the period of the experiment, model and experiment. And furthermore, we will compare some wind profiles at specific locations or times. We will see. And of course, during this evaluation period, we will communicate with the participants and organize a webinar and discuss, of course, preliminary results with the participants. The general schedule is, so officially the benchmark is launched today. I will upload detailed information, all the information which I showed here, plus some additional information to the wind vane blog. It's not yet there, but it will be hopefully by tomorrow. So you can read everything there. And I'd like to ask you, if you like to participate in this benchmark, please just contact me. So my email address will of course be in the wind vane blog. Or just ask Javier, he can also forward it. It would be nice to have an initial list of interested participants. It doesn't mean you really have to participate, but if you just think about it, just let me know. That would be nice. We intend to have the final results by the end of January, so that after evaluating the results, we could present them for example, at the Wind Europe Resource Assessment Workshop in the end of June, and at the Wind Energy Science Conference. Yeah, as said, this information will soon be posted also on the wind vane blog. These are some references, and finally some acknowledgements.